Hello students, in the previous session we discussed about matrices and the types of matrices. Now in this session we are going to see what is the scalar multiplication, transpose of a matrix, symmetric and skew symmetric matrices and addition of matrices. These are the topics we are going to cover in this session. Now first we will see what is scalar multiplication. If A is any matrix, K is any scalar, scalar means a constant, then Ka is a matrix obtained by multiplying every element of A by K. This is called scalar multiplication. Simply we can say scalar multiplication means multiplying a matrix by a scalar quantity. How we will multiply, we will see by giving one example. Let A be a matrix A, B, C, D. K is any constant or scalar, then K into A is K into our A is A, B, C, D. Now, when we are multiplying a matrix by a scalar, every element of this matrix is multiplied by this scalar. What does it mean? K into A, K into B, K into C, K into D. Every element we multiply by this scalar quantity. So we get the resulting matrix like this: Ka, Kb, Kc, Kd. So if you are multiplying any matrix A, suppose that is 1, 5, minus 1, 3 by a constant 3, you suppose the scalar you consider as 3, then 3A is equal to, every element is multiplied by 3 here, so you will be getting 3 into A 3, 3 into 5 15, 3 into minus 1 minus 3, 3 into 3 9. So if A is 1 5 minus 1 3, then 3A is 3 15 minus 3 9. Okay. Now if you take one more matrix, A is equal to 7 4 3 2 1 5. Multiply this matrix by another scalar. Let us take as 1 by 2. What you will be getting? Resulting matrix 7 into 1 by 2, that is 7 by 2, 4 into 1 by 2, 4 by 2, 3 into 1 by 2, 3 by 2, 2 into 1 by 2, 2 by 2, 1 into 1 by 2, 1 by 2, 5 into 1 by 2, 5 by 2 we get as the resulting matrix. Now here 4 by 2 as 2, 2 by 2 as 1 we can write, but this way scalar multiplication will be done for matrices. Now second one is transpose of a matrix. What is the transpose of a matrix? If A is any matrix, then the matrix obtained by interchanging the rows into columns. By interchanging the rows and the columns, whatever matrix we obtain, that is called transpose of A, and it is written as A dash or A power T. We read as A transpose. So for example, I take a matrix A as 3 minus 1 4 0 7 5 9 13. I take a matrix A. When what is this transpose of this matrix, we will see. Transpose I can denote as A dash. Now as for the definition, we can say that the rows are converted into columns. columns are converted into rows. Rows and columns are interchanged. So this is the first row of this matrix that will become first column. 3, -1, 4, 0. This is the second row, 7, 5, 9, 13, that will become second column of the transpose matrix. Now this is the transpose of the matrix A. Now one more example you can take. 1, 5, 0, 7. Then what is the transpose of this matrix? Here there is only one row, that will be one column. So this row matrix will become column matrix when it is transposed. So transpose of B is like this. Now take one more example. So C is 2, 5, 7, 3. Now C dash is first row, 2, 5 is changed as first column. 7, 3 row, second row is changed as second column, 7, 3. So now this is the transpose of this matrix. Now we will see one thing here. What is the order of this matrix? Order of this matrix is 2 rows are there, so 2 by 1, 2, 3, 4. 4 columns are there, so 2 by 4 is the order of the matrix A. Now what is the order of the transpose of this matrix? We will see. Here the number of rows, how many? 1, 2, 3, 4. 4 rows are there, so columns are 2, so it is 4 by 2. When it comes to here, only one row is there, number of columns are 4, so the order is 1 by 4. Here number of rows are 1, 2, 3, 4, and the column is only 1, so 4 by 1 is the order. Here the order is 2 by 2 and transpose order is also 2 by 2. Now you can observe that if the matrix A is of order 2 by 4, then its transpose is of order 4 by 2. Okay, rows is changed to columns, columns changed to rows. So here 1 by 4 is the order. Now the order of transpose is 4 by 1. Here it is 2 by 2, it is changed to again 2 by 2. So in general, if the order of a matrix is m by n, then its transpose is having the order n by m. If a matrix has the order m by n, then its transpose will have the order n by m. Okay, now we will see some of the results of transpose of a matrix. Suppose now we had seen what is scalar multiplication. We had seen what is scalar multiplication, that we apply for transpose of matrix also. Let us see. A is equal to 1, 5, 9 minus 4, you suppose. Then find 5a dash. If they ask find 5a dash, how we will find? First we write what is a dash. First we will write what is a dash or a transpose. What is a transpose? First row 1, 5 will become first column 1, 5. Second row 9 minus 4 will become second column. So this is the transpose of the matrix A. Now 5A transpose you have to find, that is 5A transpose. Here it is the scalar multiplication. We are multiplying the matrix A transpose by 5. So every element of this matrix is multiplied by 5. So what you will be getting? 5 into 1, 5. 5 into 9, 45, 5 into 5, 25, 5 into minus 4, minus 20. So, this is the resulting matrix. Now, if what is A transpose whole transpose? What we get if you transpose a matrix and again we transpose the given that matrix, what we are going to get? We will see by taking some examples. The same matrix you take, A is equal to 1, 5, 9, minus 4. Now, A transpose is what? We already found what is A transpose? 1, 9, 5, minus 4. This is A transpose. What we have to find now? A transpose whole transpose. That means once again you have to find the transpose. So, we transpose it once again. Then this matrix is transposed, that is 1, 9 row will become column and this second row will become second column. We will be getting the resulting matrix like this: 1, 5, 9, minus 4. What is it? You just observe 1, 5, 9, minus 4. This is nothing but A. So, what can you say? You can always say that A transpose whole transpose is equal to A itself. This is the result you have to remember. Okay. Now we will see what is Ka whole transpose. What we get when we multiply a matrix by a scalar and we transpose it, what we get we see. Again the same example we will take. Let A be 1, 5, 9, minus 4. Then according to the scalar multiplication, what is Ka? Ka is K, 5K, this is 1K, 5K, 9K, minus 4K. This is your Ka. Ka transpose. What is Ka whole transpose? Ka whole transpose is first row will become first column, that is like this. Second row becomes second column. Now what we'll be getting? We'll be getting Ka transpose like this. Now you just recall the scalar multiplication. From that we can write this one. Every element of this matrix is multiplied by the scalar K. We can also write like this: K into, by taking out the scalar quantity, you can write this as 1, 9, 5, minus 4. 1, 9, 5, minus 4 is nothing but A transpose. So, Ka transpose, Ka whole transpose is equal to Ka transpose, we can say. Now, next we will see what is symmetric and skew symmetric matrix. Now, a square matrix, here we are taking a square matrix. A square matrix, A is said to be symmetric if A transpose is equal to A. That means if you transpose a matrix, we get the resulting matrix as the original matrix, then we say it is a symmetric matrix. Skew symmetric matrix means if you transpose a matrix, then the resulting matrix is negative of the original matrix, then we say it is a skew symmetric matrix. This you can understand by observing some of the examples. Now I can give one matrix 1, -2, -2, 3, and 1, -2, -4, -2, 5, -3, -4, 3, 7. Now you just see, I had taken here two matrices, 1, -2, -2, 3. What is the transpose of this matrix? We will see. What is the transpose? 1, -2, -2, 3. This row I have written as column, this row I have written as the second column. So I am getting the transpose is like this. Now original matrix is 1, -2, -2, 3. Its transpose is also 1, -2, -2, 3. Is there any difference? No, there is no difference. So after transposing also, the resulting matrix we are getting as same. That is only the definition of symmetric matrix. A symmetric matrix is a matrix in which A transpose is equal to A. We have got the same. So we can say that this is a symmetric matrix. Now if you see here, first row is 1, -2, -4. First column is also 1, -2, -4. -2, 5, 3, -2, 5, 3. -4, 3, 7, -4, 3, 7. That means if you transpose this matrix also, we will be getting the same matrix as the transpose matrix. So you can say this is also a symmetric matrix. So these two are the examples for symmetric matrix. These are symmetric matrices. Now, how we can write? Suppose you have to write a symmetric matrix. How you can write? What is the trick to write the symmetric matrix? Or how do you recognize by seeing a matrix immediately without transpose? How can you recognize a matrix is a symmetric matrix? You see, this is the first of all symmetric matrix must be a square matrix. This is the principal diagonal. These are the non-diagonal elements. You see, these non-diagonal elements are symmetric about this diagonal. Here also, this is the principal diagonal and the non-diagonal elements are -2, -2, -4, -4, 3, 3. Those are symmetric about the diagonal. So in a symmetric matrix, always the non-diagonal elements are symmetric about the diagonal, principal diagonal. So that is the one thing you can remember to identify a symmetric matrix. Now we will see some examples of skew symmetric matrix also. 0, 1, -1, 0. One more example I am taking. 0, 3, 4, -3, 0, 7, -4, -7, 0. Now, what is the definition of skew symmetric matrix? A square matrix A is said to be skew symmetric if A transpose is equal to -A. Now I will see we will see now what is the transpose of this matrix. Suppose it is A, then A transpose is 0, 1, -1, 0. Now you take minus common from this matrix, -1 or minus common from this matrix. That means what? From every element of the matrix we will be taking minus out. So what you will be getting? 0 is 0, minus 1 will become 1, 1 will become minus 1, 0 is 0. So this is 0, 1, minus 1, 0 is nothing but A. So what you have got? A transpose is equal to minus A we have got. A transpose is equal to minus A. So it is satisfying the condition of skew symmetric. Hence this matrix we can say skew symmetric matrix. Even if you do this for this matrix, you will be getting like this matrix transpose is negative of the original matrix we will get. Such type of matrices are called skew symmetric matrices. Now again, how do you identify a skew symmetric matrix? For a skew symmetric matrix, the diagonal elements must be always zeros. That is the compulsory condition. Diagonal elements must be zeros. And the non-diagonal elements you just observe 1 minus 1, 3 minus 3, 4 minus 4, 7 minus 7. The non-diagonal elements are symmetric in magnitude but opposite in sign. If plus 3 is there, here minus 3, plus 4 minus 4, 7 minus 7. They are symmetric with opposite sign. So that is the condition for skew symmetric matrix. If you have to write or if you have to identify a skew symmetric matrix, first the diagonal elements must be zeros and the non-diagonal elements which are symmetric to this principal diagonal must be having the same magnitude but opposite sign. So in this way we can write a skew symmetric matrix. Now find x if A is equal to this matrix is symmetric. If this matrix is symmetric, find the value of x, that is the question. Now what is the condition for symmetric matrix? A matrix transpose is equal to the same matrix, then we say that the matrix is symmetric. Now here they had given that this matrix is symmetric, hence its transpose must be equal to the original matrix. What is the transpose of this matrix? 3x 4 minus 1. Rows and columns will be interchanged. That is equal to the original matrix, that is 3x 4 minus 1. Now you just recall the equality of two matrices. When we say that two matrices are equal, if their corresponding elements are equal. Now here we have to find the value of x. Here x is there, its corresponding element is 4. From this we will be getting x is equal to 4. Even if you take these corresponding elements, 4 is equal to x you are getting. So from this you can say that the value of x is 4. Now another question, find A and B if A is equal to 2A minus 1 3, B plus 1 4 is skew symmetric. What is the condition for skew symmetry? If the transpose of a matrix is equal to negative of the given matrix, then we say that matrix is skew symmetric. Now we will see what is A transpose of this matrix, that is 2A minus 1 3, B plus 1 4. That is the transpose of the given matrix. Now that is equal to negative of A, that is minus of A. A is 2A minus 1 3, B plus 1 4. Now if two matrices are equal, then their corresponding elements must be equal. So using that condition we can equate this element to this element. But before equating, you be careful, here minus sign is there, that also we have to consider. So 2A minus 1 is equal to minus of 2A minus 1. Minus of 2A minus 1, that is 2a plus 2a, this minus 2a when it comes this side, plus 2a, minus of minus plus 1, and this will become plus 1. So 4a is equal to 2, a is equal to 2 by 4, which is equal to 1 by 2. So you got the value of a as 1 by 2. Now to get the value of b, you can equate these two elements. Now we will see what is the addition of matrices. To add two matrices, there should be a condition satisfied, that is, the order of the matrices must be same. Two matrices can be added or subtracted only if their orders are same. If the orders are different, we cannot add or we cannot subtract the matrices. Only the orders are equal, then only we can add the matrices. Suppose if A is a matrix of order m by n, B is a matrix of order m by n, then A plus B is a matrix of order m by n, which is the sum of these two matrices. Now I can explain this one by taking some examples. How we will be adding the matrices? How we will be adding the matrices? Their orders must be same, and while adding two matrices, the corresponding elements of first matrix and second matrix will be added. Suppose A is equal to 1, 5, 3, minus 4, 2, 7. B is equal to 5, 8, 9, 3, 2, minus 1. Now the order of this matrix is 2 by 3. This is also 2 by 3. Now we can add these two matrices. What we will be getting as the sum, we will see. What is A plus B? A plus B is the matrix obtained by adding the corresponding elements. That means 1 and 5 we will add, 5 and 8 we will add, 3 and 9 we will add, because those are the corresponding elements. 4 and minus 4 and 3 are corresponding, 2 and 2, 7 and minus 1. So when we are finding the sum of two matrices, their corresponding elements will be added. 1 plus 5 is 6, 5 plus 8 13, 3 plus 9 12, minus 4 plus 3 minus 1, 2 plus 2 4, 7 minus 1 6. This is the sum of the matrices A and B. Likewise, we will do the subtraction also. If you have to find the difference of these two matrices, how we will be doing? If you have to find A minus B, what we will be doing, we will see. A minus B is equal to, A minus B is equal to, again the same thing, corresponding elements we will take the difference, 1 and 5. 1 minus 5. We are subtracting B from A. So from the element of A, we will be subtracting the element of B. 1 minus 5, 5 minus 8, 3 minus 9, minus 4 minus 3, 2 minus 2, 7 minus 1. So we will be getting the resulting matrix as 1 minus 5 minus 4, 5 minus 8 minus 3, 3 minus 9 minus 6, minus 4 minus 3 minus 7, 2 minus 2 0, 7 minus of minus 1 is 8. So this is your A minus B now. So this way we will perform the addition or subtraction of two matrices. Now we will see some of the properties of matrices over addition. Now we will see some of the properties of matrix addition. If A, B, C are three matrices of the same order, then A plus B is equal to B plus A. That means two matrices you can add in any order, A plus B or B plus A, both are same. You know that this is called commutative law. Now if three matrices are taken, they can be added in any order. A plus B plus C is equal to A plus B plus C. You can add B plus C, then you add A, or you can add A plus B, then you add C. You will be getting the same resulting matrix. So this is called associative law. Next one is K into A plus B is equal to Ka plus Kb. This is called scalar multiplication property. Now next one is A plus null matrix is equal to null matrix plus A is equal to A. If you add null matrix to any of the matrix, then the resulting matrix is the original matrix only, where here this is null matrix, and this law is called identity law under addition. So these are the some of the properties of matrix addition. Now we are going to solve some problems based on this matrix addition. Now we will see the question. If A is equal to 1 minus 1 2 0 0 minus 3 and B is this matrix, find 2A plus 2A plus 3B and 2A minus 3B. This is the question. Now we will find what is 2A minus 3B. 2A, now I will write directly because in the previous question already we had done. So 2 into A is 2 minus 2 4 0 0 minus 6 minus 3B is 3 into minus 2 minus 6, 3 into 4 12, 3 into 3 9, 3 into 2 6, 3 into 1 3 0. When we are doing the subtraction of these two matrices, corresponding elements we will take the difference. 2 minus of minus 6, 2 minus of minus 6, here minus 2 minus 12, 4 minus 9, 0 minus 6, 0 minus 3, minus 6 minus 0. So what we are going to get? 2 minus of minus 6 is 2 plus 6, which is 8. Minus 2 minus 12 is minus 14. 4 minus 9 is minus 4 minus 9 is minus 5. 0 minus 6 is minus 6. 0 minus 3 is minus 3. Minus 6 minus 0 is minus 6. This is 2A minus 3B. Now the next question is, find the matrix A if 2A plus B is equal to 2 0 1 minus 3, where B is equal to 1 minus 1 3 0. Here they had given what is 2A plus B, and also they had given what is B. We have to find now what is the matrix A. given 2a plus b is equal to 2, 0, 1, minus 3. So from this we can write 2a plus b is 1 minus 1, 3, 0 is equal to 2, 0, 1, minus 3. We have to find what is A. So only A terms we keep here, matrix A we keep this side, and this matrix we take the other side. So we get 2, 0, 1, minus 3 minus this matrix when it goes that side, minus 1, minus 1, 3, 0, which is equal to 2 minus 1 is 1, 0 minus of minus 1 is 1, 1 minus 3 is minus 2, minus 3 minus 0 is minus 3. We get now 2a is equal to 1, 1, minus 2, minus 3. But you have to find what is a. So a is equal to, we divide both the sides by half to get a. Both the sides we divide by 2 or we multiply by half. So a is equal to half 1, 1, 2, minus 3. So from this we get, you can multiply 1 by 2 with each element to get 1 by 2, 1 by 2 into 1, 1 by 2, 1 by 2 into 2, 2 by 2, 1 by 2 into minus 3, minus 3 by 2, which you can also write as 1 by 2, 1 by 2, 1 minus 3 by 2. So this is the matrix A. What we did, 2a plus b is given, we consider that. Next b is also given, we substituted in the place of b the given matrix. Later 2a is equal to this matrix minus the matrix b. When we do the subtraction of these two matrices, then we get the resulting matrix like this. 2a is matrix 1, 1, minus 2, minus 3, but we need to find a, so we divided both the sides by 2. So you get a is equal to half of 1, 1, 2, minus 3. Using scalar multiplication property, we multiply each element by half. So 1 into half, half, 1 into half, half, 2 into half, 2 by 2, minus 3 by 2 we get. 2 by 2 we have taken as 1. So the resulting matrix is 1 by 2, 1 by 2, 1, minus 3 by 2. This is our A. Now this question is, find x and y given that 9, 2 matrix, a row matrix 9, 2 minus another row matrix 5 minus 1 is equal to x, y. First we will do the difference of these two matrices. We find this matrix minus this matrix is what? While doing the subtraction, we will take the corresponding elements. So 9 minus 5, 2 minus of minus 1, this is the difference of these two matrices is equal to x, y. 9 minus 5 is 4, 2 minus of minus 1 is 2 plus 1, that is 3, is equal to x, y. Now when two matrices are equal, we will equate the corresponding elements. So from this we will get x is equal to 4 and y is equal to 3. Next question is, find a and b if 2a plus b is equal to 3 minus 1 minus 2, 5. A minus 2B is 4, 2, minus 1, 5. Now this question how to solve? 2A plus B is given, A minus 2B is given, you have to find A and B. This we will solve just like you used to do simultaneous equations, how you used to solve. The same way we will be solving this one. Simultaneous equations, suppose 2A plus B is equal to some constant, A minus 2B is equal to some constant. Solve these two equations means what you will be doing? One method is by equating the coefficients. Usually you will be using that method. The same method we will use here. We will try to equate the coefficients. That means here 2A is there, here A is there, here B is there, here 2B is there. So either A coefficient or B coefficient we will try to make equal. Now here 2B is there, here only B is there. So what I do, I multiply this equation by 2. So before that I will be writing the question. 2A plus B is 3 minus 1 minus 2, 5. Give equation number 1. A minus 2B is equal to 4, 2, minus 1, 5. Give equation number 2. Now I will be multiplying this equation by 2. So 2 into equation 1. So whole equation I will multiplying by 2. 2 into 2A is 4A plus 2 into B is 2B. So LHS I multiplied by 2. 2 into 2 4A plus 2B is equal to 2 into the matrix 3 minus 1 minus 2 5. So what you will be getting? When we multiply this one, we will be getting 4A plus 2B is equal to 2 into 3 6, 2 into minus 1 minus 2, 2 into minus 2 minus 4, 2 into 5 10. So this you give equation number 3. Now here 4A plus 2B is there, here A minus 2B is there. From this equation 2 and equation 3 we will try to get what is A and what is B. Now we will do 3 plus 2, equation 3 plus equation 2. Equation 3 LHS is 4A plus 2B. Equation 2 LHS is A minus 2B. Now we are adding both LHS and we are adding RHS also. Equation 3 RHS is 6 minus 2 minus 4 10 plus RHS of equation 2 is 4 2 minus 1 5. Now 2B get cancelled. 4A plus A is 5A, which is equal to, we will be adding these two matrices on RHS. 6 plus 4 10, minus 2 plus 2 0, minus 4 plus minus 1 minus 5, 10 plus 5 15. So 5A we get this one. So from this we will get A is equal to, how do we get A? 5A is this one, A on both the sides we divide by 5. So you get A is equal to 1 by 5, 10, 0, minus 5, 15. So each element is divided by 5. We get 10 by 5, 2, 0 by 5, 0, minus 5 by 5, minus 1, 15 by 5, 3. So this is the matrix A. Matrix A is 2, 0, minus 1, 3. Now we will find what is B. We got A, we will find B. To find B, we will substitute A in this equation. So that is 2 into 2, 0, minus 1, 3 plus B is equal to 3 minus 1 minus 2, 5. We just substituted the matrix A in this first equation. 2 into 2, 4, 2 into 0, 0, 2 into minus 1 minus 2, 2 into 3, 6 plus B is equal to 3 minus 1 minus 2, 5. So B is equal to 3 minus 1 minus 2, 5 minus 4, 0 minus 2, 6. When we subtract 3 minus 4 minus 1, minus 1 minus 0 minus 1, minus 2 minus of minus 2 is plus 2. So minus 2 plus 2 is 0, 5 minus 6 is minus 1. So we will be getting the value of B, the matrix B, as minus 1 minus 1, 0 minus 1. This way we will be finding the matrix A and matrix B. Solution is, while doing, we will be just using the method of solving the simultaneous equations. We equated the coefficients by multiplying the first equation by 2, then we solved for, then afterwards we added that equation and the equation 3 and equation 2, and we solved for A. By substituting A value in the first equation, we got what is B. So the next question is, if A is equal to 1 minus 1, 2, 4, B is matrix 3, 1 minus 3, 4, verify A plus B whole transpose is equal to A transpose plus B transpose, and A minus B whole transpose is equal to A transpose minus B transpose. These we are trying to verify. So first one is A plus B whole transpose is equal to A transpose plus B transpose. This one we have to verify. For that, LHS A plus B whole transpose, we find what is A plus B. A plus B is A 1 minus 1, 2, 4 plus B 3, 1 minus 3, 4, which is equal to 1 plus 3, 4, minus 1 plus 1, 0, 2 plus minus 3, minus 1, 4 plus 4, 8. This is A plus B. Now A plus B whole transpose is, we transpose this matrix, we get 4, 0. This row will become column. This row will become the second column. This is your A plus B whole transpose. Now this is equal to A transpose plus B transpose, that you have to prove. You have to verify that one. A transpose plus B transpose is what? Now I am writing A transpose directly. A is 1 minus 1, 2, 4. Transpose of this matrix is what? First row becomes first column, second row becomes second column. This is A transpose. B transpose. B is 3, 1 minus 3, 4. Its transpose is, first row will be first column, second row will become second column. So this one is equal to A transpose plus B transpose. We add these two. 1 plus 3, 4. 2 plus minus 3, minus 1, minus 1 plus 1, 0, 4 plus 4, 8. A plus B whole transpose is 4 minus 1, 0, 8. A transpose plus B transpose is also 4 minus 1, 0, 8. So from this, now we verified A plus B whole transpose equal to A transpose plus B transpose. This is verified. Now second part, A minus B whole transpose is equal to A transpose minus B transpose. This also we will verify. First we write what is A minus B. A is 1 minus 1, 2, 4 minus B is 3, 1 minus 3, 4. This is equal to 1 minus 3 is minus 2, minus 1 minus 1 is minus 2, 2 minus of minus 3, minus of minus 3 is plus 3, so 2 plus 3 is 5, 4 minus 4 is 0. This is your A minus B. Now what is A minus B whole transpose? We will transpose A minus B, minus 2 minus 2, 5, 0. This is A minus B whole transpose. This is equal to A transpose minus B transpose. You have to verify. So A transpose minus B transpose is what we write. A transpose is, transpose of A is 1 minus 1, 2, 4 minus transpose of B is 3, 1 minus 3, 4. Now the difference is 1 minus 3 minus 2, 2 minus of minus 3, 2 plus 3, 5, minus 1 minus 1 minus 2, 4 minus 4 is 0. Now you see A minus B whole transpose is minus 2, 5, minus 2, 0. A transpose minus B transpose is minus 2, 5, minus 2, 0. Both are same. So you can say now A minus B whole transpose is equal to A transpose minus B transpose, which is verified. So with this question, the questions on matrix addition are over. In the next session, we will do what is, we will see what is matrix multiplication, and we do some problems related to matrix multiplication. Now we conclude this session with this question. See you in the next session. Have a good day.